Now, today we're looking at forces in equilibrium. This is a mass hanging suspended from two tension strings. We're going to call this tension 1. We're going to call this tension 2. Now, the tension force is broken up into two components. The first component we'll look at tension 1 is directed along the x-axis. The second component we're going to call y1, part of tension 1, and it's directed along the y-axis. So that's x1, that's y1. Now, this angle we will call theta, and according to the rule of angle, side, angle, side, angle, this is also equal to theta. Now, since this is the x-axis and that's the y-axis, that makes this a 90-degree angle. And if we look at and analyze the T2 component, the force component for tension on the right-hand side, we break it up into two component parts, the x direction and the y direction as well. In the x direction, we're going to call this x2, and in the y direction, we're going to call this y2. This is also 90 degrees, but this angle we're going to call beta, and by angle, side, angle, we call this beta as well. Alright, so if we look at x1 and tension 1 and y1, tension 1 is pulling the mass upwards. That means that the x1 component pulls to the left and the y1 component pulls straight up. If we look at the T2 force, the x2 component pulls to the right, which is directly opposite of x1, and the y2 component pulls straight up, which is in the same direction as y1. If we look at these forces and break them up using sine and cosine, we have to analyze the triangles individually. So I'm going to rewrite tension 1, x1, and y1. It's a 90-degree angle, and that is our angle theta. Sine theta is equal to y1 over t1. That means that y1 is equal to t1 sine theta. Cosine theta is equal to x1 over t1. So x1 equals t1 cosine theta. All right, analyzing the second triangle on the right-hand side, 90 degrees, we call this T2, we call this x2, we call this y2. This is beta. Sine beta is equal to y2 over t2. So y2 is equal to t2 sine beta. Cosine beta is equal to x2 over t2. So x2 is t2 cosine beta. Now, this just breaks up the forces into components along their directions. What we now need to do is sum the forces in the x and y direction. We learned earlier that the sum of all forces are equal to mass times acceleration. So the sum of the forces in the x direction are going to be equal to x2 minus x1 or x1 minus x2. It doesn't matter which way you go with it because in this case the object isn't moving, so the acceleration is equal to 0. So x2 minus x1 is equal to ma, which is equal to 0, and that ends up meaning that x2 is equal to x1. So this is why it doesn't matter if you say it's x2 minus x1 or x1 minus x2. Now, if we look at this and see what we just solved for here for the components, x1 is t1 cosine theta, and that's equal to x2, which is t2 cosine beta. All right, now that's the sum of the forces in the x direction. Now let's sum the forces in the y direction. There's a y component for y1 that's pulling up, a y2 component pulling up, and there's a force that we left out. That's the force of gravity, and that's mass times gravity in the downward direction. So you have y1 plus y2 minus the force of gravity being equal to ma, and since it's not moving anywhere in the y direction, that's equal to 0. So y1 plus y2 minus f sub g is equal to 0. y1 plus y2 is equal to f sub g, and the force of gravity is mass times gravity. Now we make our substitutions. Y1 is equal to T1 sine theta, and Y2 is equal to T2 sine beta. That's equal to mass times gravity. And now we have two equations. We have the sum of the forces in the x direction, and that gives us T1 and T2. And we have the sum of the forces in the y direction, that also gives us T1 and T2. But with two equations and two unknowns, we have to use one of the equations to solve for the other. So I'm going to solve T1 here. So T1 is going to be equal to T2 cosine beta divided by cosine theta. Now, if T1 is equal to this, and we have a T1 in this equation, we can substitute this into T1 here and then solve for T2. All right, so we end up with T2 cosine beta divided by cosine theta. All right, that's T1 times sine theta. So times sine theta. That's this times this. So this is the numerator. That's a numerator. That's the denominator. Plus T2 sine beta. And we're going to have to erase that. Equals mg. Sine over cosine is tangent. So this becomes T2 cosine beta tangent theta plus T2 sine beta is equal to mg. Now, we factor out T2. This becomes cosine beta tangent theta plus sine beta is equal to mg. And finally, T2 is equal to mg divided by cosine beta tangent theta plus sine beta. This is our final equation for T2. If you plug in the numbers for mass, gravity, beta, and theta, you'll get a number for this force. Punch this number in to here to get the value of T1.